sixth graders, this looks a little different. We are gonna do a little bit of a lesson through your packet, so make sure you have that out and ready, or if you have the electronic version, if you are a Digital Academy kid that did not decide to pick up a packet at school. So you can see there's some vocab words at the top. We're gonna talk about percents. There's a lot of different ways that people can do and work with percents, and you're gonna have some choices, and you do what works best for you. So let's review a little bit what a percent is. A percent is a ratio that compares a number to 100. So it is a ratio, which we're going to talk about also. We review that word, that compares a number to 100. I'm writing kind of funny. To 100. Remember, we think per cent per 100. A ratio is a comparison of two numbers. So that is why a percent is a ratio, is because it compares a number to 100, two numbers. Comparison of two numbers by division. And so you can write a ratio two different ways, or multiple different ways. You could write it 2 to 3, 2 to 3, or as a fraction, 2 to 3. You could also say 2 out of 3. Remember, ratios are the only type of fractions, if it's an improper fraction, that we don't simplify, because then it would no longer be two numbers. And you know a fraction is a quantity that is not whole. So we are usually comparing a part to a whole, not whole. Okay, so we usually compare some sort of part compared to a whole. So that's a quick little review. This goes along with our standard 6113. Our goal is to understand percents, that they are part of 100, and they are the same as ratios, and they can be fractions too. So I'm going to do a couple of these in the next couple slides, and then you're going to try a couple based on what you know, always focusing on what you do know rather than what you're not sure of yet. So carry on with me here. So you are welcome to, sit and think about how would I try these first if you'd like, and then come back and try the ones that I do with you. So 36 is 40% of what number? So there's a couple of things that you could do. There's something called a percent equation and something called a percent proportion. It simply is that we can know that a fraction can be written as a percent, or they can be written equally. So we know that 36 that means it's a part, a certain part of a number that is the same as 40%, which we could write as a fraction, 40% of another number. Of what means we don't know what it's out of. So you could set up like a proportion like that, and if you remember, you could do cross products to solve. So we could multiply here and say that 3600 should be the same as 40 times what number? And then we have a one-step equation. We undo that multiplication with division, and we'd end up with 90. X is 90. And of course, you could plug it into check to make sure that those fractions could simplify to the same thing, and that'd be a great way. So 36 is 40% of 90. It makes sense because I know 50% of 90 is 45, and that's relatively close. Another thing you could do, if you wanted, is percent equation, and that just means that you're using those symbols again to write out the words. So 36 means equals 40% as a decimal, of means multiplication, what we don't know, what number. Then you could solve that equation by dividing 36 by 4/10. Since you know that percent means per 100, and you see that this is a 10 by 10 grid, you could figure out what percent is colored in, we're going to assume this is orange, by knowing how many are filled in out of 100 and write it as a percent. You try it. Using the information you know from above, we have this question here. Riley has 200 stamps. That sounds like a total to me. 35% are from Europe, 10% are from Asia, 20% are from Australia. The rest of the stamps are from North America. How many stamps of Riley's are from North America? So this means the rest are. So what we might want to do, I'll get you set up here, is add these up, and then the remaining percent out of 100 should be the percent that we don't know. You can find out the percent of the 200 would equal your answer. So you're going to multiply your percent as a decimal times 200. For the next one, some good things to try. Again, you could do that percent proportion, where we know it's percent out of 100 is the same as a part of a number out of a whole number, and use what you know there, or We know that percents can be written as decimals. Of means multiplication. We don't know, you can use a variable. And then you can solve using inverse operations. Good luck. Hey, it might be useful to you and to come to class with this ready to circle the statement that best matches your personal understanding of today's benchmark. On each of these slides, you'll see one of these. Read the description and circle the one that you think best fits you today. All right, so for this learning target, we are looking at 6114. This is where we can determine equivalencies between fractions, decimals, and percents. We've done this before. You've done this a lot. So let's try a couple. We have that Pamela and Ella are trying to finish their math homework before their favorite TV show starts. Pamela finishes 95% of her problems. Ella finishes 65 out of 74 of her problems. Who finishes a greater percentage? So they're asking who has the greatest percentage, but we only have one of them in percentage form. So we're trying to decide which one of these, 95% or 65 out of 74, that's a fraction, is greater. Remember to change a fraction to a percent. You can change it to a decimal, right? This is the same as division, and then multiply that decimal by 100. A decimal times 100 gives you a percent. See if you can figure that one out based on what you know. The same method will be true here. We're trying to decide, is 76.9% greater than, less than, or equal to 12 out of 32. So what you could do is change this to a percent to be able to compare them. Remember, fraction, we can do numerator divided by denominator to get a decimal, and we can multiply that decimal by 100 to get a percent. On the bottom, which numbers are equivalent to 18 over 72? Select the ones that are true. So I know that we have different percents and fractions. So what I know is that 18 over 72 is not simplified. I see that they both share a factor of, say, well, I know for sure 2. So then I get 9 over 36. Those share a factor of 9. Oh, I see that one right there. Those share a factor of 9. So that's the same as 1/4. That isn't an option, but I know that 1 out of 4 is the same as 25 out of 100, or 25%. So that's also the same. Because it's multiple choice, I'm going to make sure I look at these and figure out if I think any are equivalent. I don't think they are, so I'm done. Last one here. Nancy owns 1/5 of a gas stations in Columbia. In Benton, Christy owns 17% of gas station. Who owns a greater percentage? So again, you could change them to percents or fractions, whatever you feel is best. What I know as an equivalent is that 1 out of 5 is the same as equivalent to 20 out of 100, right? I can multiply these both by 20. So I know that 20 per 100 is 20%. 20% is greater than 17%. So that would mean, I better reread my question. That would mean it says who, so then I would know that 1/5, that means that Nancy has a greater number of gas stations. Super important learning target here is that you can calculate the percent of a number and determine what percent one number is of another to solve problems. Let's try a couple of these. Again, multiple different ways, so if you want to try first and then come back and check, you sure can. Tucker's class held a class election. 90% of the 30 students in the class voted. How many students voted? So I know that 30 is my total, and I know that 90% of the 30 is what I'm looking for. So I could set up an equation, so I'll show you the multiple different ways. So I might be able to say 90% as a decimal of 30 is what number? I could just multiply, right? Percent of a number, you just change it to a decimal and multiply. That's the same, if you don't like decimals, as doing as a fraction. So I know 90% is the same as 9/10. You can see that those are the same, of 30. And I might feel better about this, because I might say, well, I know 1/10 of 30 is 3, and I want 9 of those tenths, so that is equal to 27. That means that 27 students voted. You can use that same information to help you solve this one, percent of a number. Change your percent to a decimal, right, by just moving the decimal 2 places to the left, and then multiply. On this one, Elizabeth's Cafe has regular coffee and decaffeinated coffee. This morning, the cafe served 56 coffees in all. Sounds like a total. 42 of which, of the total, were regular. What percent of the coffees were regular? It sounds like you're going to have to set up a fraction and change that fraction to a percent. Do you remember how to do that? If the denominator can go to 100, that's one way. Or you can change it to a decimal and then multiply by 100 to get that percent. So I think this question is written a little poorly, but we're going to go with it. We have 250 calendars are being printed in an hour. 75 are printed. We want to know what percent of the calendars are printed. So we're going to say, okay, we have 75 of the total 250, and we know that we can change to a decimal. And when we change it to a decimal, then we can multiply that by 100, and we can get our percent. What do you think? All right, last bit of practice, friends. Here, we're trying to figure out if we can solve real-world problems that require fractions, decimals, and mixed numbers. And then we're also working on our estimating. Sometimes estimating is a good way to just say, hey, about how many? So looking at Avery's question here, Avery has a purple ribbon and an indigo ribbon. The purple ribbon is 8 7/12 inches long. The indigo ribbon is 7 1/4 inches long. How long, got to read the question. The indigo ribbon is longer than the purple ribbon. How long is the indigo ribbon? So it's longer than, and we know the purple ribbon, so we know that's going to be in addition to, so we want to add those. And so if we add those, what you need, I'm just going to give you a little hint, is you need a common denominator. So can you get these fractions, before you add them, to have the same denominator, and then you will add the whole number and add the numerator and leave the denominator alone. Go ahead and try. See if you can activate that prior knowledge. Over here, we're going to estimate. Newport River held a nest of fish eggs. The nest contained a total of 974 eggs. If 312 of these eggs hatched, about how many did not hatch? So that means we're kind of subtracting, and it's about how many. So we could do some rounding, right, and round maybe 974 up to even 1,000. And we could do 312 is approximately 300. And since we know those hatched, we're wondering how many are left over and didn't. Subtract 700. Couple more to try. Bailey feeds dogs at the Humane Society. Each dog gets 41 pounds of dog food per day. How many dogs can Bailey feed with 532 pounds of food? So we know that this is going to happen per day. So we're wondering, this is going to be probably a division question. And it's about how many. So can you divide 532 divided by 41? Give it a try. Last one, kind of out of left field, little different. We have a data set. Stem and leaf plot here. So we have our stems. These are really our tens place. And this over here is our ones place. And the key helps us figure it out if we're unsure. So that means that is a 10, and that means 14. So then we have multiple 16s. This says mode, and if you remember mode means which one happens the most. Who's got the most? So then you can look to see which number appears the most. I see 27 shows up twice, but I see 16 shows up 3 times. Awesome. I hope you guys have a great day. Remember to go through each slide and kind of decide, where do you think you are? Do you feel like you are not meeting the standard? Are you partially meeting? Do you meet, or are you exceeding? And again, there's a description there. Do your best. Have a great day.